Hey, welcome back. Today, let's talk about 7 tips for writing clean code. Now, what do I mean by clean code? Well, as programmers, we are writing code. That means we are typing stuff into the keyword, into an editor. And the more easier it is to read, the easier it is to maintain for ourselves in a couple of weeks when we are going to revisit some functions that we've written, some part of the code. It's easy to, get lost in the complexity. Writing code is a kind of an abstract thing. Well, it's not a kind of abstract thing. It's very abstract. So it's important for us to help ourselves, our future self, or others when we're working in a team, to maintain this code, to extend this code, to modify that code at a later date. So that's the importance of clean code. Now, let me give you 7 examples of how you could achieve clean code. And the first one is naming conventions. You gotta be descriptive and consistent in naming parts of your code, variables, methods like reusable building blocks that you're using. And that sort of goes hand in hand with the tip number 2, that's code formatting. You need to be consistent in your formatting. Maybe the indentions, that are very important in Python, for example, the line length when you are automatically wrapping into the next line, how you use white space like space characters, or if you use tabs. And there are definitive code formatting rules or guidelines depending on the programming language that you use or depending on the company or the team that you're working on. There's PEP 8 or POP 8 for Python. There's standard JS for JavaScript. You can use something called linters, which we won't get into right now. But naming conventions, code formatting, very, very important so that you're able to, don't really need to switch your brain around a different style of formatting whenever you read code from somebody else or when you switch to another project. Very important. Tip number 3 goes also hand in hand with writing clean code. You need to document and comment your code. You can have inline comments to explain what the code that you're writing below actually does. You can have block comments in a certain style so that it's easy to auto-generate documentation from it later on, like a README or API documentation, as block comment above a certain class or function or part of your code. And again, the idea is to help yourself or help somebody else remember and get what the code that's written below actually is doing, what it's supposed to be doing, how it's working. Obviously, you don't really sort of duplicate the stuff that's already there. If you have a print statement, that means you output something to the console. You don't write your comment, okay, this is outputting something, but maybe you explain why it's outputting something or under which conditions it does that, or why it makes sense that it's actually outputting this here right now. And of course, I'm simplifying here, but you get the idea. You explain the context and maybe certain preconditions and requirements for the code or internal workings of the algorithm that you're doing, that you're just coding in the comments and in the documentation. And that, again, helps you write a clean code. Tip number 4, modularity. You don't write code from scratch into one line, spaghetti code, as we like to call it, in the 70s and 80s. No, I didn't start in the 70s, but I had my first touch points with the programming language and my first frustrations with BASIC on my Commodore 64 in the 80s. So modularity, not spaghetti code, but breaking code into smaller reusable components like functions or classes. Object-oriented programming is all about reusable components, right? So let's say you need a functionality to validate the user's input, whether it constitutes a valid and legal email address. So, email addresses have a certain format to them, right? There's something before the @ sign, right? And there's something after the @ sign, and usually there's a .com or .something top-level domain afterward. So when users are entering an email address in several parts of your application, you don't really copy that thing. You make it modular and you write the code to validate what the user has entered and whether it's a valid email address. You write this once and then you can use that many times. That's the principle of modularity. Tip number 4, which goes hand in hand with tip number 5, which is basically don't repeat yourself, the DRY principle. You want to avoid redundancy. You want to avoid repetition by using functions and classes, reusing code to fetch data from an external API, as external website or backend. You want to reuse code to format dates, maybe. So that's the 5th tip here for you. Tip number 6 is error handling. Error handling means that you want to deal with errors that can occur in your code, not because you let them in there, but maybe something else is not working. Maybe the internet access isn't available right now. So you want to deal with that sort of unexpected situations in a consistent and in a manner that doesn't really alienate the user, right? And you want to handle network errors. You want to handle inputs that have been collected from the user or from somebody else. And if it's not working, if it's not the correct kind of input, you want to react in a way that makes sense to your project, to the functionality. And finally, testing. The importance of tests. You want to ensure your code reliability. There's something called test-driven development. It's a principle that you may want to abide by, and you want to start with writing a test for the functionality that you are about to code, right? So you test something that's not already there, so the test will fail, and then you're going to write code that satisfies the conditions and the test that you've just written. So TDD, test-driven development, again, a topic for a whole course, not just a podcast episode. But how you deal with testing is something that you want to think about, that you want to discuss with your teammates when you have the intention to write clean code. And really, finally, refactoring. Refactoring is the practice of improving code quality and maintainability by maybe removing duplicated code or improving performance. So you don't really add new features there, new functionality. You make what's already there more reliable, better maintainable. Refactoring a function to use a loop instead of recursion, which is something again that we haven't really talked about in this podcast yet. But it uses more memory and it has some performance implications if you do it one way, like we're using recursions, than using a loop. And you want to refactor the code. It does exactly the same, but it's more efficient and it's better maintainable. So there you have it. These are my tips for writing clean code. Naming conventions, having consistent code formatting and a way to comment and document your code, thinking in modular, reusable, smaller building blocks, reusable components. That's the principle of modularity, and don't repeat yourself. Having a proper way to handle errors, thinking about how to test your code, and refactoring your code every once in a while to make it more efficient, to make it better maintainable.